that how we will design some little basics regarding the pressure vessels. Okay, so some students are asking that how much weightage of this part is. So weightage point of view, I told it is only of 1 or 2 mark. Okay, from gate point of view. Okay, and from the last 9 years, from the last 9 years, 9 to 10 years, there is no question from the designing in the gate examination. Okay, so it doesn't mean that there will be no question again. There may be question, but it will not be a tough question. Okay, and but interview point of view means after you give the gate examination, for interview purpose you should have a good basic in this subject. Okay, so that we will see. So now we will see contactors. Okay, which is in the syllabus. Okay, we will see contactors. So basically, contact us this year again. What is the application? It is related to the HETP, height equivalent to theoretical plates. Okay, NTU and all these terms will be related to the mass transfer. So you will be seeing in the subject, that is absorption in mass transfer. But how they work actually? Okay, okay. Um, Yes, contactors are also in mass transfer. Okay, so there actually you will design the absorption tower. Okay, so at that time you will get a real feeling of that. Okay, contactors. I will give you the basics that why they are used and what is the different types of contactors. Okay, so we can say that they are basically, okay. This is related to the, you can say, mass transfer. Okay, they are basically a plate or tray contactors. Okay, it is used in basically plate column, tray column in absorption, in distillation, and all that. Cross flow plate. Okay, cross flow plate. Cross flow plate are the most common type of plate contactors used in the distillation column. Okay, so this is basically, you will see very much detail in the distillation column in the mass transfer. Okay, so there are three types, mainly three types. Okay, which is used in the industry. So mainly these are three types basically. So first one is the sieve tray. Okay, first one is the sieve tray. Okay. So basically, what is our main motto behind this contactor is that we want a good contact of gas and liquid. Okay, we want a good contact of gas and liquid. Okay, because the more the contact will be between them, more the mass transfer will be taking place. So just for example, if you see it is a distillation column, so some liquid is going downwards and some vapors are coming upwards. Okay, so this is the thing in absorption column also. You can see that suppose it is a air ammonia mixture and water is there. Okay, so ammonia will try to go from air to water, so absorption will be done. When ammonia is going from water to the air, it will be a stripping. Okay, so what is the difference between, okay, what is the difference between the stripping, absorption? Okay, this you are going to see in mass transfer in very much detail, and you will be designing that. Okay, actually how many number of trays will be there, how many number of all that components in distillation column, also how many number of trays are there, how to calculate McCabe method. Okay, what is LS minimum, GS minimum, there are various factors. Okay, so that you all going to see in the mass transfer. Okay, so I think after Diwali, your mass transfer subject is going to start. Okay, and the sir is very good. Okay, so pay attention and he will give you the best. Okay, so sieve tray. Okay, so what is, you can say this is the simplest type of. Okay, this is the simplest type of cross flow plates. Okay, basically what is the idea here in the sieve tray? It is like this. Okay, suppose Suppose it will be like this one. Okay, your tray will be like this. In between some gas will be there. Sorry, gap. Okay, sorry, gap will be there. Okay, so this will be like this. Okay, I will draw with actually black color. Okay, it will be like this. Okay, then what will happen here? Okay, your vapors are coming from down. Okay, your vapors will come from down here. Okay, from the gap the vapors will go up, and upper part is filled with the liquid. Okay, upper part is filled with the liquid. It is totally filled with the liquid. So the gas will go, there will be the contact of the gas. Okay, here. Okay, so these are the gas molecules, so they will come in contact with that. Okay, so this will be like this. Okay, inside the column it will be like this. Means one tray will be there, some gaps will be there. From that gaps, this red color I am representing it for the vapor. Okay, and the blue color will be representing for liquid. Okay, so from that gap vapors will go up and it will come in contact with the liquid, and between them basically what will happen, mass transfer will takes place. So this is simple, there is nothing that it is a plate, and plate you can say there will be some holes will be there. Okay, in the plates there will be some holes will be there. Okay, so due to this what will happen, this phenomena will taking place. Okay, so what flow rate you should maintain of gas and liquid, actually that you will see in the mass transfer. Okay, there are certain terms, flooding, whipping, okay, channeling, there are certain terms in the mass transfer. Okay, that is you are going to see there. Okay, actually, so that will maintain a particular optimum flow rate of the gas and liquid. Okay, because what will happen if there is not maintain optimum flow rate of gas and liquid, what will happen, there will be sometimes it may happen that liquid will not come in contact with the vapors. Okay, so this may happen. Okay, so this may happen. So due to that there will be certain, okay, so due to that there will be certain whipping process and all that. So this you are going to see in detail in the mass transfer. Okay, basically because at what flow rate you have to maintain the system, that is going to be given by the governing equation. Okay, and first you have to derive the governing equation. Okay, and all that you have to do there. Okay, in the mass transfer, basically in absorption is a very big topic in the mass transfer, and you are going to see it in detail. Second is the basically, okay, second is the bubble cap. Okay, second one is the bubble cap. Okay, second is the bubble. You can draw this diagram. Okay, bubble cap. So how bubble caps work? Okay, I will explain you. This will be there. So what exactly flow rate you have to maintain, that you have to calculate. Okay, and that you will be doing in the uh, and that you will be doing in the here mass transfer subject. Okay, so what is this bubble cap? Obviously the name gives us idea, there will be the cap here. Okay, to maintain the vapor flow rate there will be the cap like this. Okay, there will be the cap like this. Okay, so you can see here also cap like this. So am I audible, Hari, Keshav? Little bit my voice is coming properly? Okay, okay. I think Harikeshav checked your system actually. Everyone is writing. It is crystal clear. Yeah, loud also. Okay. See, so this is a cap. So what will happen here? When the vapors will go, okay, when the vapors will go from here, okay, what will happen? there will be enough time for them, okay, because it will be surrounded by the, okay, because up to here it will be surrounded by the liquid, okay, it will be surrounded by the liquid from here all the way, it is a liquid, okay, it is a liquid. So what will happen, your vapor will go from here, okay, and okay, your vapor will go from here like this in direction, and from here it will come to upward, okay, it will follow like this structure, okay, so they have enough time for the contact, okay, so they have enough time for contact. So, okay, and this upper part is known as cap, this upper part is known as cap, basically that is why it is known as bubble cap, okay. Or sometimes what will happen, there will be a chimney like structure here, okay, chimney like structure will be there, so that chimney like will be means here some partitions will be there, okay, so what will happen, when the vapors will go from here, okay, they will come out of the chimney, okay, and there will be the bubbles, okay, there will be the formation of bubbles, okay, everywhere. So it has a good contact of liquid and gas, okay. So bubble cap tray has a riser or a chimney fitted over each hole and a cap that covers the riser, okay. So what is riser, this is known as riser, okay, where there is a beam which is known as riser, okay. So the cap is mounted so that there is a space between the riser and cap to allow the passage of vapor. Vapor rises through the chimney and it is directed, okay, downwards by the cap, finally discharging through slots in the cap and finally bubbling through the liquid on the tray. Okay, so this is the thing. So here what is happening here, basically gas is directly going and coming in contact with the liquid in the sieve tray, okay, but in the bubble cap you say they have to travel a certain amount of distance, okay, so at particular flow rate they will be going through that, so more bubbles will be created and all that, so that is why you can say that it is better than bubble cap, okay. But obviously the pressure drop will be high, because why, because the gas is going upward, okay, so there will be the obstruction in front of that, okay, okay, there is a obstruction, so that is why you can say pressure drop will be more. So if pressure drop is more, then the flow rate will be reduced, so it means more time will be there, okay, more time will be there in the, as compared to the sieve tray like in the bubble cap, okay. So this you can write a bubble, you can write this actually, a bubble cap tray has a riser, a bubble cap tray has a riser or chimney fitted over each hole, okay, fitted over each hole, and a cap that covers the riser, okay, and a cap that covers the riser, okay. So this is a riser in that, okay. Enough time means basically contact time is more, okay, 220334. To sir, please discuss bit more in detail. Yeah, I am telling in detail, okay. Equations you will be seeing in mass transfer, okay, there is a derivations and all that in mass transfer, okay, okay, this is the thing. Pressure drop, why there is a pressure drop, you are doing the fluid mechanics in the morning batch, na? Tell me roll number 220034, when there will be the pressure drop in the system, when there will be the high pressure drop in the system, tell me. Anyone can tell when there is a high pressure drop in the system. Obviously more turbulence will be there, okay, more turbulence will be there, there will be the pressure drop in the system, obstruction. So yes, there will, here there is a obstruction, okay, so due to obstruction pressure drop will be more. So when pressure drop is more, there the gas will lose their pressure drop, so what will happen to that system, okay, they will give a more contact time, okay. Okay. So if you compare sieve tray and bubble cap, which one is good from efficiency wise? Which one is good? If I compare sieve tray and bubble cap, which one will be good for the efficiency wise? Obviously, the bubble cap will be more efficient. Okay, bubble cap will be more efficient in am I audible now? Okay, okay. So there is actually power cut due to this. Okay. Yes, contactors are nothing but okay. Okay, contactors are nothing but to increase the contact time of liquid and vapor so that more mass transfer will takes place. Okay, this is the main application of this contactors. Okay, so this is the thing with we are doing. Okay, yes, 21176. Okay, okay, so there is third type also. There is third type also, that is valve tray. So first I will draw the diagram of valve tray. Okay, so it will be fitted with some valve. Okay, there will be valve here. Okay, so what will happen when there is a valve here? The gas will go. Okay, the gas will go from here like this. Okay, or I can say just arrow I will draw. Gas will go from here. Okay, and it will go from here. So the amount, okay, the amount how much the gas is going from here, it will depend upon the how much this wall will be lifted. Okay, it means that basically that vapor flow rate will decide, or you can say pressure will decide, vapor pressure will decide. Okay, the pressure of this vapors, okay, means the fluid will decide that how much it is going. Okay, the fluid how much it is going. Okay, sorry, I have used I think wrong color. For bubble, I will be using red. Okay, like this. Okay, like this. Here also it will go. So if we lift more, then more gas will go from here. Okay, more gas will go from here, and obviously it will be filled with total liquid. Okay. So basically in this, what is there? There's a cap is there. Okay, so it can be freely moved. But here valve is there. Okay, so more pressure will be required. So basically where we use valve plates, basically where flap. It is a movable flap which lift as the vapor lift increases. Okay, as the vapor lift will increases, it will lift. Okay, so basically this will be used where there is a high uh, a lift by the vapors. Okay, okay. So wall tray, you can write in the wall tray, it is covered by liftable caps. Okay, in the wall tray, it is the hole is covered by liftable caps. Vapor flows, vapor flows lift the caps. Okay, vapor flow lift the caps, thus self creating a flow area, thus self creating a flow area, self creating a flow area for the passage of vapor, for the passage of vapor, for the passage of vapor. The lifting cap provides better mixing. Okay, the lifting cap provides better mixing than in sieve trays. Okay, the lifting cap provides better mixing than in sieve trays. Okay, it means that when there will be no vapors, when there will be no vapors in the system, the this cap is closed. Okay, this cap is closed. As the vapor is increasing, it will lift more. Okay, so more vapor will come, more lift will be there, and more vapors will go outside. Okay, yes, you can say it is just like a pressure cooker whistle, means enough pressure is built up, then it will release it. Okay, so basically that much amount of pressure you have to maintain in that system. Okay, for a good mixing, because I have told it is good for mixing. So when mixing is good, turbulence will be more. Okay, and turbulence is good for the heat transfer and mass transfer. Okay, turbulence is good for the heat transfer and mass transfer. Okay, mixing is good for heat transfer and mass transfer. Okay, so when mixing will happen, when turbulence will be there in the system. When turbulence will happen, when there is an obstacle in the system. Okay, so that is why we want a good mass transfer in the system. Okay, so depending upon various factor, if you see that maintenance point of view, maintenance point of view, which one will be costlier? Maintenance point of view, which will who will require more maintenance? Okay, maintenance will be more in the valve. Always remember one point. Okay, whenever there is a more moving parts in the system, always remember, or you can write this point, whenever there is a more moving parts in the system, it required a more maintenance. Okay, so sieve tray will having the least maintenance. Okay, sieve tray having the least maintenance. Okay, and more maintenance will be in the valve trays, because that bubble, that cap is moving to up and down. Okay, that cap is moving in valve tray, that valve is moving up and down. Okay, so that you can say. Okay, so least will be in the sieve tray and more will be in the valve tray, and you can say in middle bubble cap, but bubble cap and valve tray mostly you can say it is similar, but better answer will be valve tray. Okay, always remember one point, that whenever there is a more moving parts in your system, it required a more maintenance. Why? Because see here, vapor is there, liquid is there, that there may be the corrosion in the system. That corrosion may degrade the life of your valve and bubble. Okay, so that is why the maintenance is more in the system. So see, this valve and bubble are creating, okay, this valve and bubbles are valve tray and bubbles tray are creating hindrance, and due to hindrance, you have studied in the fluid mechanics, due to hindrance there will be more mixing, and due to more mixing, what will happen, a good heat transfer and mass transfer takes place. Okay, so that is why a better mass transfer will takes place in valve trays and this bubble cap. Okay, so this is the point. So always remember, but what is the drawback of this? There are two drawbacks of using valve trays and this bubble cap. What is the drawback? First one is the maintenance is more, second one is the pressure drop is more. Okay, so that you have studied in the fluid mechanics. Okay, why there is a pressure drop more when there is a hindrance in your system. Okay, so depending upon the quality or product, we will choose wall tray, sieve tray or bubble cap. Okay, so these are the points. Okay, so you can draw this actually. Okay. Okay, so most frequently we will be using sieve tray. Okay, most of the application we are going with the sieve tray. The condition where you can say the vapor flow rate is very less, then you can go for a bubble cap, because what will happen? Hindrance is there. Okay, so that hindrance will create a good mixing in your system, and that mixing will be good for your mass transfer. Okay, so this is the thing. Okay, so basically we know that a good mixing, whenever there is a good mixing, it will help to have a good mass transfer in your system. Okay, so these are the three trays which we have done: sieve tray, bubble cap and valve trays. Okay, so it doesn't there are various parameters. Okay, so basically a contactor's time of, if I see, then it depends on this factor in the contactor. Okay, there is no question on this. Okay, this is purely an interview. Okay, yes, lifting cap provides better mixing, and mixing is good for mass transfer. Okay, why only tray? Why not packed? Yeah, you can do for packing. Na? In tray, I am telling this. Okay, in tray column, I am telling this. Okay, so you can go for packing also. There are some packings. Okay, so the column will be like this. Okay, so it will, suppose this is a sieve tray. Okay, and it is full of liquid. Okay, it will full of liquid, then the liquid come from here. Okay, liquid will come from here, then it will be like this. Okay, then again it will be full of liquid. Okay, the alternate way, the liquid will go and the vapors will going here. Okay, so this is the vapor rising. So in this way you can say the liquid and vapors will come in contact. Yeah, in single column also you can use combination of contactors. Okay, you can use. Okay, and these vapors will go from here also. Okay, like this. Okay, then we will see difference between difference between pack and tray column. Okay, so I will give you some points. The plate column can be designed to handle a wider range of liquid gas flow rates than packed column. Okay, as the packed columns are not suitable for very low liquid rates. Okay, the efficiency of a plate can be predicted with more accuracy in comparison to packing. Okay, in the tray column, it is easy to make provision for the withdrawn of side stream. Okay, so means basically you can easily make a provision for side stream in the tray column. In the packed column, you can't do like this. Okay. Sorry. So write these points. Okay, in the tray column, it is easy to make a provision for the withdrawn of side stream. Okay, I will explain these 3 points. See, the plate column can be designed to handle a wider range of liquid gas flow rates than packed column. Okay, as the packed columns are not suitable for very low liquid rates. Okay, so for very low liquid rates, what will happen? It will not have a efficient energy, or you can say pressure, to pass through your packing. Okay, so that is why we will go for plate column. Second one, the efficiency of plate can be predicted with more accuracy. Why? See, suppose you have a packed column. Okay, suppose you have a packed column like this. Okay, so you can't predict that how much, what is your efficiency at this point, this point, this point. Okay, but if it is a tray column, you can calculate efficiency of each and every plate. Okay, so that is the meaning of second point, and that is also third point. Means basically, if you want some product from this, suppose this is one, two, three. So if you want product something from two, you can withdraw that product. Okay, but in packing you can't do, because packing you have to wait up to the full packing when your product will come. Okay, so this is your third point. Fourth point. Fourth point. It is easier to make a provision. It is easier to make a provision for cooling and heating at different section in tray column. Okay, means basically each tray you can put it at different temperature. Okay, so that is the benefit of tray. Okay, so it is easier to make a provision of cooling and heating. Okay, next, for the corrosive liquids, for the corrosive liquid, packed columns are better, because packing is cheaper. Okay, because packing is cheaper. Yes. Okay. Sixth point, pressure drop is more in tray column. Okay, it means it is less in packed column relatively. Okay. So for corrosive liquids, we will prefer packing. Okay. Packed column have a low pressure drop. Okay. Okay. Seventh and the last one. Okay. Packed column are favorable for small diameter vessels in which it is difficult to make provision for the tray. Okay, in which it is difficult to make provision for the tray. Okay, and one more thing, means it is easy, that cleaning will be easy in tray. Okay. Okay, so these are the points. So write these all the points. So now I will see doubt section. Turbulence is more in plate towers. Yes, so that is why you have given answer, na? Delta P will be more. Yes, Harry. So delta P will create more turbulence in your system. Okay. Okay. Plate and tray columns are same. Yes. Pressure drop I have told, na? Yes, 211459. Sixth point, what I have told, delta P is more in tray column. Yes, it is right, na? The in which part turbulence is more, delta P will be more. What is wrong in that? This you have studied in fluid mechanics, na? Whenever the pressure drop is more, it means more turbulence. Okay. See in this, okay, I hope you have written all the points. In packing, what will happen? It will be like this. Okay. So there will be always space for vapors to go easily. Okay. It will travel a something path like this, but they can easily move. Okay. In tray column, but what will happen? There will be more. Here it will go. Then again it will be the in this direction they will go, and there if you are using a bubble cap and tray column, in that it will happen. Okay, that will leads to a pressure drop. Then I will give you the difference between the fluidized bed and packed bed. Okay, suppose you have fluidized bed and packed bed. Yeah, you are right. 211 11176. Okay, vapor needs to penetrate. Okay, see, packed bed and fluidized bed. So if I want to compare both of them, which one will be good? It depends on various factor. But in CRE, I hope you have seen that plug flow is better. Okay, plug flow is better. Okay, you have seen in the CRE like this, plug flow is the better reactor. But you have seen all also that point also, it is very difficult to design a plug flow reactor in the real life. Okay, in the real life it has very complications. Okay, for a plug flow reactor in the system. But once you make a plug flow reactor, it is will be very difficult to control that flow rates, but efficiency point of view it is very good. Okay, so I think some part I have told in the CT also. So for plug flow, uh, you have seen that the velocity should be, okay, velocity should be flat. The velocity should be flat. Okay, so in that there should be not no slip boundary condition. No slip boundary condition is done in your fluid mechanics. Okay, if it is done, then it is good. Okay, it is done, na? Okay, okay. Okay, so no slip boundary condition basically means the fluid velocity equals to zero at the boundary. Okay, so here there is in the flat velocity or in the plug flow velocity there is no slip boundary condition. No slip boundary condition. Okay, so which fluid has that property? Ideal fluid. Ideal fluid has that property. Reynolds number equals to rho Vd by mu. So it will be mu equals to 0 for ideal fluid. So 1 by 0 equals to infinity. Okay. So if you want to see the fluidized bed and packed bed. Okay. Fluidized bed and packed bed. So how suppose in this is fluidized bed. It will be like this. And packing it will be like this. Okay, so which reactor, this is both are one type of reactors. Okay, so which reactor will behave as a plug flow reactor? Which reactor will behave as a plug flow reactor? Packed bed or fluidized bed? Suppose this is 1, this is 2. Okay, so the answer is packed bed will behave as a plug flow reactor. See, suppose some liquid is going up. Okay, suppose the liquid is going from here. So at every point you will see that the liquid layer will be like this. And here it will not be same like this. It is coming in contact with this, sometime this, sometime this, sometime this, sometime this, sometime this. Every particle has different velocity. So see, it is the profile of flat velocity. Here also it is a flat velocity. Okay, so that is why packed beds are better. Packed beds are better to control. Okay, fluidized bed we use mostly for some solid gas reaction. Solid gas reaction in the CRE. Okay, so basically if you see here, okay, this is fluidized. Okay, first one is fluidized, second one is the packed. Okay, okay, so this is the thing. It will be very difficult to operate a fluidized bed, okay, because keeping the particles in the suspension form is very difficult. Okay, if you see the Argon equation and all that, there the sphericity will come, and due to this, keeping the pressure drop constant for all the particles at the same time is very difficult. So that is why it is very difficult to operate a fluidized bed in the chemical industries. Okay, so first preference is always given to the packed bed. Okay, when you are going from some solid reaction, solid gas reaction, you will be first preference will be giving packed bed. Another important point is that packed bed will behave as a PFR, and we know that PFRs are better reactor as compared to the other reactors. Okay, so that is why this is again an interview question actually. Okay, they can ask you that which one is good. Okay, so hope you have all understood this point, packing versus fluidized bed. Okay, So one thing always remember that mixing is not good for reaction. Okay, mixing is only good for, you can write this point actually, mixing is only good for, mixing is only good for HT and MT. For reaction, for reaction, okay, mixing is not good. You have seen, okay, suppose you have a plug flow reactor and if there is axial mixing, okay, axial mixing, so then it is not good. Okay, we want to avoid that axial mixing. Okay, so that is why a reaction mixing part is not good. Okay, so in peer, in packed bed, we are seeing all the particles are moving. Okay, in particles here, all the particles are moving here. Okay, in one direction only, flat velocity. Okay, here mixing means I am telling about axial mixing. Okay, don't think about radial mixing. Obviously there will be the radial mixing in the PFR. Okay, I'm talking about axial mixing is not good for reaction. Okay, design of packed bed, you can say is easier as compared to the fluidized bed. Okay, in which reactor is temperature control easier? Which reactor means which, CSTR or PFR? Obviously temperature control is good in CSTR. Okay, yes, I'm talking about axial mixing is not good. Okay, so you can tell me one reaction in which the mixing is good. In which mixing is good. Okay, one reaction. There is only one reaction. Yes, autocatalytic reaction. Okay, this you can remember. Autocatalytic reactions are, okay, autocatalytic reactions are good in mixing. Okay, temperature control. Yes, it is good in fluidized bed. Okay, you are talking about packed bed or this, no? Yeah. Okay, so hope this point is clear to everyone. Okay, mixing is only good for heat transfer and mass transfer. In reaction, axial mixing is not good, and this is the point. Okay, then we are going to see the pump. Okay, so pump, basically there are two main types of pump, that is the centrifugal pump. Okay, centrifugal pump. Second one is the positive displacement pump. Positive displacement pump. Okay, So, if I talk about the application wise, then the centrifugal pump is used 90% in the chemical industries. Okay, 90 to 95% you can say. Okay, and positive displacement pump is used, you can say 10 to 5% in the chemical industry. Okay, so that is why centrifugal pumps are very important in our daily life, means in our household also we use centrifugal pump. Okay. So can anybody give me the example where you use positive displacement pump? What is your question? Ideal CSTR has infinite mixing. Yes. Okay, in that there is an infinite mixing. Moving bed reactor, slurry reactor, rotary kiln, fixed bed reactor. Yeah. What is your question? Okay. Yeah, then CSTRs are not good, na? CSTRs are not good. Okay. Okay. Tell me where we use positive. I'm not asking the screw pump, gear pump. Okay. Don't tell me this. Okay, so positive displacement pumps basically we use where the high pressure drop is there in the system. Okay, high pressure drop in the system is there. Okay, so high pressure drop means we need a something like dosing. Okay, if you do a dosing in the chemical industry, okay, we use a positive displacement pump, or you can say packed column. In packed column also we use positive displacement pump. Okay, or you can say in your aqua guard, if you have seen your aqua guard, there also we use there also we use basically a positive displacement pump. Okay, what is dosing means basically something like this. Suppose one pipeline is moving on. Okay, one pipeline is moving on in this, that some fluid is there. Okay, so if you want to enter some little amount of chemical here, okay, in between that, so it will be from dosing. Okay, it will be done by the dosing, and here we use PD pump. Okay, our heart is also a one type of PD pump. Okay, if sometimes if heart fails, then artificial hearts are positive displacement pump. Okay, yeah, syringe is basically a positive displacement pump. Okay, syringe is a positive displacement pump. Okay, moving bed reactor, slurry reactor, rotary kiln, fixed bed reactor, this is not in the syllabus. Okay, PED. So syringe is one type of syringe is one type of positive displacement pump. So that is like a dosing, okay? Means if you want to give some dose to your body also, it is like a dosing. We use positive displacement pump. In our home we use a centrifugal pump, okay? In our home we use a centrifugal pump, and that is the a special type of centrifugal pump. I will explain, okay, what is that. But first we will see. So these are the common applications of positive displacement pump, okay? Dosing, pack column, your heart, okay? And in aquaguard also, because there is a packing of that filters are there, so that is why there you will be using diaphragm pump, okay? Diaphragm pumps are used, okay? So reason that most of the time we are not, okay, the reason that most of the time we are not using the positive displacement pump, because the flow rate which we are getting from the positive displacement pump is fluctuating. It gives a fluctuating flow rate, okay? So that is the reason why we are not using a positive displacement pump, okay? Suppose I will try to explain you from diagram, okay? It will be like some piston, okay? So what will happen, suppose this is an inlet, this is outlet, and there will be the check valve here, okay? There will be the check valve here. So what is check valve? Check valve basically unidirectional flow, okay, which is also known as NRV, non-returning valve, one direction flow, okay? One direction flow. So what will happen here basically, due to this, once the piston will move, it will travel a certain amount of distance. Suppose here it is filled with a liquid, okay? Then the next position of piston will be like this. So it will give a pressure, but after, when it goes up, okay, when it will goes up, what will happen? The piston will move back, okay? So due to the movement of back piston, there will be the some time. If you see the water flow rate versus time, it will be coming like this, because this is the time which you are getting the flow rate, okay? But when the piston will go back, there will be the no flow rate outside, okay? So that is why it will be coming like this. So that is why there will be the fluctuation in the system, okay? There will be the fluctuation in the system, and that is not good for any reactor, okay? That is not good for any reactor. That is the thing, we avoid to use a positive displacement pump. There are certain methods which are used to reduce the fluctuation in your system, okay? Okay, there are certain systems where you can use the way you can reduce the fluctuation, but it is not 100% eliminated. Okay, you can reduce the fluctuation, but it is not 100% eliminated, and it is also costly. Eliminating the fluctuation from this positive displacement pump, it will be very very costly. In that way, we go for a centrifugal pump in the system. Okay, so in this way, there will be to and fro system in the this piston. Okay, to and fro will be there in the system, and what will happen? Uh, For every cycle, a constant amount of flow will be go. So that is why these pumps are known as constant volume pump. Okay, different types of pumps and all that you are going to see in the fluid mechanics, okay, that I am not telling, but they are known as constant volume pump. Why they are known as constant volume pump? Because see, when the this is the initial position of your piston, when it will move forward, it will push certain amount of fluid in this direction, okay, then it will go back. So for every time the amount of fluid it is pushing, it is constant, okay? For every time the amount of fluid it is pushing, it is constant. That is why it is known as constant volume pump. Okay, so that is why it is known as constant volume pump. Okay, you can write this actually. You can write all these points. Okay. So anyone has doubt regarding this can ask. Okay, I will explain why constant volume. Okay. Why name given positive displacement? Because it is moving in the positive way to move the fluid. You said that valve controls pressure drop, not flow. Yeah, that valve basically will change the create obstruction. Na? Yeah, I will explain. Will you teach FBR and PBR design expression? What is FBR, PBR? Fluidized bed reactor and packed bed reactor. This you are going to see in fluid mechanics, na? Argon equation and all that. Okay. So this is not in this syllabus. This is in fluid mechanics syllabus. You are going to see argon equation, minimum fluidization condition, and all that in fluid mechanics. Yeah, I will explain constant volume. Okay. Okay. So see why it is known as constant volume pump. See here. Okay. See this distance. When this is the condition at time t equals to 0, this is the initial condition of your piston. Okay. After some time, what will happen? This crank will move, okay, and this rod will be straight, and this will push the liquid, and your water will go or any fluid will go in this direction. Then this piston will again go back. So the amount of fluid it is pushing when it is going from here to here, okay, the amount of fluid which is the piston is pushing from going to here from this time t equals to 0 to some time t equals to t, it is always same. Okay, it is always same. Okay, it is always same. That is why this is known as constant volume pump. Means for every this piston displacement, the volume which is coming out of from the centrifuge, this positive displacement pump is same. So that is why it is known as constant volume pump. Okay. No, it is not negative displacement pump. No. Okay. Okay. So this is the thing basically in the system. Okay. So everyone got this point. What is constant volume pump? Okay. So this is very good interview question. They ask that constant volume pump and constant this pump centrifugal pumps. You can write this now. I will explain. Centrifugal pumps are known as constant head pump. Okay, you will write this. I will explain by theory. Okay, why they are known as head pump. But write this. But you can remember this point that positive displacement pumps are known as constant volume pump, specifically this reciprocating pump, and centrifugal pumps are known as constant head pump. Okay. So the advantage, one most good advantage of this positive displacement pump over centrifugal pump is that there is no cavitation here. Okay, there is no formation of cavitation. So what is cavitation? I will explain. Okay, first, just it has a advantage that there is no cavitation. Basically it means there is less chances of formation of bubbles in the positive displacement pump. Okay, there are less chances of formation of bubbles in the positive displacement pump. Okay, this NRV means non-returning valve, means the flow will be only in one direction. Okay, the flow will be only in one direction, that is known as NRV. Means if you put NRV here, the flow will not move to this direction, it will not go back. Okay, it will move only in one direction. So that is NRV, non-returning valve, which is also known as check valve. Okay, so the only disadvantage of the positive displacement pump is the formation of sorry, the flow, outlet flow is fluctuating. Okay, the outlet flow is fluctuating. So what we do basically, okay, what we do basically, suppose this is the type. Okay, I will draw a diagram. Wait. This is piston. Okay, so basically it is giving always a constant volume, so that is why these are known as constant volume pump. Okay, they are known as constant volume, and centrifugal pumps are known as constant head pump. Okay, so see what will happen. To reduce the fluctuation in our system, we will fill this with pressurized air. Okay, we will fill this chamber with pressurized air. So what will happen when the piston will come to this position? When the piston will come to this position, what will happen? The fluid has more density. So some fluid will go in this direction. Okay, some fluid will go in this direction and some will be here. Okay, it will remove the air in the system and it will be there. Okay, but when the piston is coming back, what it will do? The fluid is here is under pressure. Okay, why? Because it has removed the air in that. Okay, so what will happen when the piston is going back? The duration in which the fluctuation in coming, it will give the liquid to this system. Okay, some amount of liquid it will give the moment this piston is going back. Okay, the moment the piston is going back, at that time the liquid is given by this air vessel. Okay, this is known as air vessel. Liquid will be given by this air vessel. Okay, this is the point. So here also it will happen that some fluid will go here. Okay, so when the chamber is going back, so instantly it will fill your system. Okay, instantly, because this is the direction of fluid here and this is the direction of fluid here. Okay, so what is happening here? Here the fluid is going in two ways. Here also it is going and in this chamber also going. But when piston is going back, obviously the fluid will not go here. The at that time the fluid is going from this air vessel to your pipe. Okay, at that time the fluid will go from this air vessel to your pipe. Okay, so this phenomena is used basically to reduce fluctuation. To reduce fluctuation, we use this. Okay, to reduce the fluctuation, we use this. Okay, so it will help to reduce the fluctuation. It is known as air vessel. Okay, this extra part is known as air vessel and it is used to reduce fluctuation in flow rate. Okay. Or what we can do for reducing the fluctuation. Okay. Okay, or what we can do to reduce the fluctuation. Suppose this is like this. Okay, your piston is going, so you can give, suppose like this and this. Okay, there will be two inlet and outlet. Okay, so it is connected to the your crank. Okay, it is connected to the crank. So what will happen when this piston is moving back, it is also filled with the liquid, so liquid will go here. When it will go forward, the liquid go from here. Okay, so this phenomena is also used. Okay, this phenomena is also used to reduce the fluctuation. Okay, means two inlets and two outlets. Okay, so this is the thing. Okay, so this is also used to reduce the fluctuation in our system. Means what is happening, see what is the difference between here when the piston is going back, there is no fluid available, but in this, when the piston is going back, fluid is available here, and when the piston is coming forward, the fluid is available here. So okay, so both will be connected and your one outlet will be made. Okay. Okay, so this is the point. Okay, so this is the point here. Okay, two inlets and two outlets, and the third is the most costliest one. You can put the reciprocating pump in series. Okay, you can put the reciprocating pumps in series, and that you can do obviously, but series will increase your so much cost. Okay, so you can do, so in most of the some industries we follow this reciprocating pumps in series, but still there will be some fluctuation in your system. Okay, so now everyone is comfortable how to make, how to reduce the, how to reduce the things. Okay, how to reduce the fluctuation. Everyone is clear? Parva, when I'm saying something, you are interested in asking question. Okay, and when this is over, you are saying that you are not understanding, when all the students are writing that they have understood all the things. I have seen so many times that when I explaining something, you are writing some questions, sir. Will you cover this? Will you cover that? That you can ask at the end, na? I am explaining, concentrate here. When I am explaining something, you are interested in some other questions. When everyone is saying that they have understood the points, and you are saying that I have not understood anything, these three at all. It means your concentration is writing the doubts. I will explain, but at least when I'm explaining, concentrate here. I told now doubt session. Then you write your doubt session. Na? I have seen so many times that when I'm telling something, you are writing doubt there. What is the point? How can I will, while explaining something, I can read your doubt. Okay, this will not possible for me. You can ask doubt. Okay, that is in the syllabus. I will cover. Okay, this is also is not in the syllabus, but I am covering because these are most good interview section. Okay, it is not that if I want to cover all interview questions, it take me almost 60 to 70 hours. Okay, but I am covering that those questions which are most frequently asked in the interviews. Okay, it may happen that whatever I have taught here, it is not asked to you in the interview. They will ask you another question. It may happen. Okay, but due to time constraint and all that, I have some limitations. Okay, So concentrate here. When I say doubt session, at that time you can write your doubt. Okay. See, air vessel. See, what is the drawback? What is the drawback of this? Basically, means positive displacement pump. The fluctuation is very more. Okay. So why fluctuation is coming, Akparva? Because the piston is going back and the piston is coming forward. Okay. So the moment it is going back, the water is not coming at the outlet. Obviously, when the piston is going back, the water will not come outlet. So that is why there is a fluctuation. But at one time, we will get more water. At one time, we will not get any water. Okay. But what we will do, we will insert some air vessels. Okay. In that, it is filled with the air. So what will happen when the pressurized liquid is going, it will go to the pipe and also it will go to this air vessel. Okay, it will remove the air present in that. Okay, and that liquid will be under pressure. Okay, when the piston is again going back, the pressure is released. Okay, now that liquid will move to the main pipe. Okay, now that liquid will be moved to the main pipe and again it will be filled with the some amount of air. So again this for the bottom section also. Okay, when it will suck, some liquid will be go there. So when it is going forward, some liquid may go into this section so that it will increase the some amount of flow rate. Okay, so this is about the air vessel. Means when the piston is going back, so at that time there is no water is going at the outlet. So at that time this air vessel will provide some amount of water. I am not saying that it will give the same flow rate. Okay, it will give some amount of water so that your system, your graph will not come to zero. Okay, so that your graph will not come to zero. Okay, Akparva, now you have understood. Akparva, now you have understood or not, or anyone else? Now it is clear to all. Mechanism means what? Basically mechanism you are asking. I have told now, mechanism is piston is going forward. This is mechanism. Piston is going forward, piston is going back. So when the piston is going back, the fluid is coming out of this air vessel. So this is mechanism. Okay. Now see this two inlet, two wall system. Okay. Okay. The structure of air vessel will be like this. Okay, it will be cylindrical like structure. Okay, structure of air vessel will be like cylindrical. Now see two over inlet, two outlet. So what will happen in the two inlet and two outlet? First time the liquid will enter from here. Suppose this is one. Okay, I have to increase the some. Okay, suppose this is one and this is second inlet. So initially the fluid will enter from the first inlet. Okay, so this piston will go and it will go from first inlet. Okay, the moment it is in the first this piston is here to near to the first one, this second will fill the tank with the, or you can say container with the liquid. So when the again piston has to go back, here also piston has to go back. In the first diagram also piston has to go back, but when it is going back there is nothing, no liquid available. But here it is two, it will fill with the second inlet. Okay, from second it will be filled. So again the water will come to the out from the second. Again it will go from 1 to 2. Means every cycle it is come, not cycle, you can say one way it is completing, it is pushing the some amount of fluid. So this is also used to reduce the fluctuation in your system. Okay, and third one is connecting them in the series. Okay, connecting in series. Okay, when you have in series, so basically what will happen, it will help to reduce that. Okay, but series will increase your cost so much. Okay, series will increase the cost of the pump so much. Okay, so depending upon application and all that, we select, okay, one, two, or three, depending upon availability, cost, and so many factors. But these are the three ways from which we can reduce the fluctuation in the flow rate. Okay, series is costly. Okay, series is costly. Why? Because you have to make us containers in series. Okay, like this. Again you have a piston. Okay, you have to piston. So you have to maintain a piston angle in such a way. Okay, this calculating angle is very important. Okay, this is another a big study, how to calculate this angle. Okay, because every moment it will move a 360 angle. Okay, so at first position the piston will be here, second position the piston will be here, third position piston will be here. Okay, so basically you will be requiring these three container and all that. Okay, so that is why connecting them in series, this will be a one big box. Okay, and this is one outlet and one inlet which is connected to all, so it will be a costlier. Okay, that is why series is costly. Okay, so these are the things for the. No, they are not design alteration. Okay, so basically design alter, it is just to reduce the fluctuation in the pump. Okay, it is just used to, these three alternates are used to reduce the fluctuation in the pump. Okay, okay. Apurva, connect in parallel. So why we connect something in parallel? I think this you have studied in the CRE. Okay, anybody can give answer. When we connect something in parallel, hmm? Yes, to increase the production. Okay, so it is not going to increase your efficiency. So we are interested in increasing the efficiency. Okay, only the production will increase when we add something in parallel. Okay, yes. Okay, so that is why there is no need to add in parallel. Okay, you can add, but you are just increasing the amount of flow rate. Okay, okay. Design of air vessel, it is just a cylindrical box type. Okay, there is no design for that. Okay. So one thing, most important thing is that in the positive displacement pump, the efficiency is greater than, is greater than. Can anybody tell what is in which it is greater than? Can anybody tell? Okay, PD efficiency can be greater than Q actual, or you can say Q actual can be greater than Q theoretical. Q actual is greater than Q theoretical. What is the meaning of this? This is very important point. Q actual is greater than Q theoretical. Means if in CRE, if you see, if you are calculating the efficiency, something 90%. So can it be greater than, efficiency can go, or conversion can go beyond 90%? No, the conversion can't go beyond 90%. If you have calculated it theoretically, it will be always less than that. But in centrifugal pump, it happens. Okay, in centrifugal pump, whatever you will calculate from theoretical, the Q will be more than that. Okay, the reason behind is that, see, the reason behind is that there are, means you can say a lot of technical reasons. I will give you one simple reason. Okay, so that is understandable to you. Okay, or okay, see, this is inlet, this is inlet, this is outlet. So when the piston is moving back, when the piston is moving back, if you increase the, if you have a very good RPM, okay, if you have a very good RPM, and your pipe diameter is larger, inlet pipe diameter is larger. Okay, and your outlet pipe diameter, you calculate it lesser. Okay, inlet pipe diameter is lesser and it is larger. So what will happen when the piston is going back? When you have a higher pipe diameter, there is no friction. Okay, no friction is not correct word, less friction. Okay, this we have studied in fluid mechanics. Okay, so don't tell me the reason behind that. This we have studied in the fluid mechanics. Okay, whenever the pipe diameter is larger, it will have a less friction. So when the friction is less, when the this piston is moving back, okay, when the piston is moving back, this fluid is coming from here. Okay, this fluid is coming from here. Okay, it will be filling your container. Okay, but when the piston will push the liquid, when the push the liquid, okay, what will happen? The fluid which is available in the pipe, it has some momentum. Okay, it will have some momentum. Okay, so it will not stop 100%. Okay, it will not stop 100%. So what will happen? Even though the piston is coming forward, some amount of liquid is coming here, and at the same time it is going outward also. Okay, some amount of liquid is coming from here. So there are two reasons for that. Because the diameter of the pipe is larger, and you have studied in the fluid mechanics that when the diameter of the pipe is larger, it has less friction. So if there is no friction or less friction, or you can say best word is less friction, the fluid will move forward. Okay, the fluid will move forward. Okay, and due to this what will happen? And again, there is a momentum. What is momentum? If you see like that, if you are going in a bike, okay, if you are going in a bike and you apply a sudden brake, okay, if you are going in a bike, you apply a sudden brake, what will happen? The vehicle will stop, but your body will not stop. Okay, your body will try to move forward. Okay, अगर किसी ने एकदम से जोर से ब्रेक लगा दिया तो जो पीछे वाला इंसान रहता है वो आगे आ जाता है. क्यों होता है? बिकॉज तुमने ब्रेक मार के फ्रिक्शन को यूज करके व्हीकल को स्टॉप किया, लेकिन तुम्हारे बॉडी के मोमेंटम को स्टॉप नहीं किया. वो बॉडी क्या चाहती है? अभी भी आगे ही जाना चाहती है. The body will try to move forward even though you have stopped your vehicle. So same thing will happen with this fluid here also. Okay, whenever you will apply a stop to the fluid, but the fluid tries to come into this container, so some amount of fluid will come into the container. As your body, when you in the vehicle, as your body wants to go forward, similarly here also the fluid wants to go forward even though we have stopped. So theoretically we have stopped the fluid, but practically the fluid is coming. Okay, so that is why the Q actual, okay, that is why the Q actual is greater than Q theoretical. Okay, that is why the Q actual is greater than the Q theoretical. Okay, so this is the point. Okay, so listen once again. Okay, listen once again. I'm giving you example. You are moving in a bike. Suppose you are moving in a bike at a speed of 70 km per hour. Okay, okay, you are uh, moving in a bike for a 70 km per hour, and instantly you apply the brake. Okay, instantly you apply the brake. What will happen? You can do this experiment. Okay, you can instantly apply the brake. What will happen? You can do it at a slower speed. Okay, don't go for 70, 30, 40. You can do instantly apply the brake. What will happen? If you have seen in the movies also. Okay, if something will come into your body instantly. Okay, what will happen? Your body will come forward. Okay, why your body? Because your body is moving with some momentum, and you can't stop a momentum at a one position. Okay, due to this what happen? Your body will come forward. Same thing happens with the fluid. You have stopped the fluid from coming inside. Okay, you have stopped the fluid from coming inside, but that fluid has some momentum. Okay, that fluid has some momentum, so some amount of fluid will come into the chamber. Even though theoretically it should be stopped, but practically due to the momentum available in that fluid, some amount of fluid will come into the tap, and you have increased the diameter of the pipe. Okay, so fluid mechanics says when you have increased the diameter of the pipe, friction will also reduce. Because who is going to stop that fluid? Friction. If more friction is there, fluid is going to stop. Fluid is going to stop. But as the friction is also less, momentum is also high. So these 2 points will lead to the fluid will go inside the container, and that fluid will be pushed by the piston. Okay, so in that way, the Q actual will be greater than the Q theoretical. Okay, Q theoretical. So this is the thing. Okay, So that is the coefficient of discharge and all. There are so many things. Okay. So basically you can say negative slip occurs. Okay. So for that delivery pipe should be diameter is less. Okay. Suction pipe diameter should be high. Okay. So this is the thing. So everyone got this point. Okay, so there are mathematical calculations also for this. I'm not going to do this. Okay, so because this is not in syllabus, I have just told that so many times. They just ask in the interview that why Q theoretical is, sorry, why Q actual is more in Q theoretical, because this is not going to happen in the centrifugal pump. Okay, this is going to happen in the only positive displacement reciprocating pump. Okay, especially in reciprocating pump. Okay, so there are two types of positive displacement pump, that is reciprocating pump and rotary pump. Okay, okay, okay. So Shant, you have said that you have read this before, but you have not understood at that time. Okay, now you can read this theory. Actually, this is very good theory. Okay, so what interviewer will ask, can the Q actual will be greater than Q theoretical? And we have always think that obviously never we exceed the theoretical value. Okay, whether it is CRE, whether it is a mass transfer, whether it is a heat transfer, we never exceed that. But only in this pump we exceed the theoretical value. Okay, so that is a positive thing for us. Okay, hope everyone got this data. Sorry, this concept. Yes, you can say increasing inlet dia will reduce fluctuation, but it is not so much effect. Okay, main thing is momentum. Okay, reciprocating is constant volume. Now I told so many times, Aparva. I have written also. See, centrifugal pump, constant head pump. Okay, and it is constant volume pump. Okay, Aparva, I have written all the things. Okay, so everyone got this. Rotary pump is basically when the chamber is not constant. So suppose screw pump, diaphragm pump, peristaltic pump are rotary pump. So what is that you are going to see in detail in fluid mechanics? Okay, I'm just telling some interview questions which are frequently asked. Okay, so I will be not teaching the working of any pump or anything. Okay, that you will going to see in fluid mechanics. Actually, it is a part of fluid mechanics. Okay. I told na two types of positive displacement pump are rotary pump and reciprocating pump. And the whatever I am telling, it is all about the reciprocating pump. Okay, I am telling all about the reciprocating pump. Yeah, valve controls the pressure drop. Okay, not flow. Why we use valve? Okay, why we use valve basically to control the flow. But our continuity equation says A1 V1 equals to A2 V2. So actually we are not controlling the flow rate. Q1 equals to Q2. We are controlling the pressure drop. Okay, we are controlling the pressure drop because you are creating an obstruction. What you have studied in the fluid mechanics. Okay, you are creating an obstruction, and whenever you are creating some obstruction, what will happen? Whenever you create obstruction, what will happen? Turbulence will occur there. The moment turbulence will occur, more pressure drop will be there. More pressure drop will be there in the system. So that will leads to the energy loss in your system. Okay, so that is the thing. Okay. So everyone got this point. If anyone has doubt, can ask. So tomorrow lecture we are going to see the centrifugal pump. Okay. So any doubt regarding this, you can ask. Similarly, there is one thing in the cooling tower also. Okay, in cooling tower, you go beyond the temperature of that air. Okay, because there is a one concept dew point temperature. Okay, so at that time also we have a more efficiency. Okay, than theoretical. Cooling tower also topic is there. Okay, so in that, if someone has doubt, you can ask. Sunday will be the last lecture. Okay, Sunday. Okay, tomorrow, if there, Sunday will be the last lecture. NPSH, I will tell you short, okay, but questions and all that will be covered in fluid mechanics. Okay, I will give you short description. Okay, but that is the main part of a fluid mechanics. Okay, so any other doubt you can ask, or I will tell you some points. Anyone has doubt? Anyone can ask? Any doubt? Series. What this means? Series. This reciprocating pumping series. So what will happen? See here. Here the position of each and every piston is different. So when the fluid is moving from here, when it is coming back, it will be in this position. So it will be giving the flow. So when it is coming back, this will reach to the this. Okay, so due to this, what will happen? Alternately, we have to adjust angle such that ultimately the fluctuation will be reduced. Okay, ultimately the fluctuation will be reduced. Okay, so if you see our heart, okay, our heart is also a positive displacement pump. Okay, positive displacement pump. So what is in the heart? There are arteries, and I have one homework I will give you: arteries and veins. So both have the same diameter. Both have the same diameter or different? Hmm? Both have the same diameter or different? Can anybody tell me? Yes. Both. Okay. Arteries and veins both have different diameter. So which one is greater? Which one is greater? Arteries. Very good. Arteries are greater. Okay, so they are inlet. They give blood to the heart. They are inlet. They provide blood. And veins are outlet. So their diameter is less. Okay, their diameter is larger. Arteries have a larger diameter, veins have a less diameter. See, they are working as a pump here. Okay, I have just told outlet lesser diameter, inlet greater diameter. Okay, so same thing is happening with the heart also. So, okay, so that is why heart is also a positive displacement pump, in which arteries are the inlet having a greater diameter and veins are the outlet having a less diameter. Okay, so see, means whatever is your body. Okay, okay, whatever in your body is there. Okay, whatever is in your body is there, you can study. It is basically a totally a fluid mechanics. Okay, it is totally a fluid mechanics. Okay, so it is basically you can see in detail and all that. Okay, what means our body we can say that blood is flowing from one part to another point, so they are just generally pipes and all that. Okay, so this is the thing. So basically, body is full of fluid mechanics, so you can say that is biofluid mechanics is the new subject which is just introduced in the engineering section. So here in this part, so the engineers study about the body, how the fluid is moving, how heart is working, how kidney is working, because everywhere there is a fluid, transportation of a fluid. And whenever there is a any choke in the flow rate, okay, means basically BP is there, blood pressure will increase. Heart attack is means that when you are not getting a fluid, okay, when you are not getting a fluid to the heart, okay, for a moment, for a moment also if you are not getting a fluid, it will give you a heart attack. So there are some technical words in that, okay. Okay, so this is the thing. So basically a positive displacement pump will always take care of, okay, positive displacement pump will always take care when you need a very high pressure, okay. Whenever you need a very high pressure, positive displacement will take care. So similarly if you see that in the packed column, initially you need a very high pressure, okay, because it is a packing is there, packing available is there, okay. So that is why whenever it is a, suppose it is a sand filter, okay, whenever it is a sand filter or any filter is available, you will be using a positive displacement pump, okay. So this is a very good example. And whenever suppose this is a pipe and you need to give a dosing of some chemicals here, okay, you want to enter some drop of chemicals there, so what it will do, we will be using some positive displacement pump, okay. Here we are also using positive displacement pump, okay. Whenever you will be using, suppose I have told that if you want to give an injection to our body, okay, so it will be syringe like that, again it is a positive, you are pressing it like a piston, okay. The syringe is like a piston, you can see that, okay. The doctors, the injection they give, it is piston is there, it will go forward and it will come into your body, okay, it will come into your body. So these are the best examples where positive displacement pumps can be used, okay. So in chemical engineering point of view, I told the positive displacement pumps are only up to 5 to 10%, okay. It is only up to 5 to 10% of this is there. From chemical engineering point of view, most of the time we are talking about the 90%, we are using a centrifugal pump, okay. We are using centrifugal pump, okay. This is the thing. So this is the thing, suppose there is a limitation, okay. Always remember that these pumps are designed, okay, pumps are designed basically to push, okay. They give very easily push, means वो धक्का आसानी से दे सकते हैं. It is similarly like that, if I tell you to move the table, okay, or move the almirah, which one is easy, push or pull, okay, which one is easy, push or pull? If I tell you to move the almirah, which one is easy, push, okay. Some students are writing pull. This we have done in 11th 12th class, okay. Basic mechanics, push is easy, okay. Push means from behind you are giving the force, obviously, means most of the students have written correctly push, still some students are writing pull, okay. So please remember, push is always easy, okay. Push is always, it is very difficult, means you are coming in front of almira and you are pulling the something, it will be very difficult, rather than you go back of the almira and you just push it, okay. At that time it will be easy. So in the same way, for pump, push is easy, push is easy. So what this exactly mean is that, suppose you have a one column, okay. Suppose you have a column and you have an option, you can put pump here, you can put pump here, so you can put pump here, okay. You have three conditions, this is first condition, this is second condition, this is third condition. So which one will be easier, which one will be easier, first, second, third? Okay, and from this you have to go here. Okay, I will give. Okay, suppose this, every water should be go want to go here. This is your tank. Okay, so which one will be easy? First, second, third? Okay, wait a second. Okay, so wait, one concept I think I have told wrong here. Pull is easy. Okay, wait, some student has written, yeah. Pull is easy. I am talking about Almira. Okay, I have to actually tell you regarding the pump. Yeah, here, pull is easy. Okay, so this, sorry for the mistake in my mind. Actually, I am talking about pump. Okay, so here pull is easy. Okay, while talking about Almira, but for pump, actually push is easy. Okay, I will tell you the reason and also that. So pull is easy. Okay, I'm correcting my statement. Pull is easy. Okay, and speaking, I'm saying always push. Okay, that is why. See here, what will happen to this system? First, second, or third. In this, the third position is the best one. Okay, third position is the best one. Why the third position is best one? See here. Suppose I'm talking about first position. In first position, the fluid has to travel this amount of distance. Okay, the fluid has to travel this amount of distance. Okay, so what will happen during this traveling of distance? Okay, during this traveling of distance, friction, due to friction, what will happen? Due to friction, the fluid temperature may increase. Okay, due to friction, the fluid temperature may increase. Okay, due to friction, the fluid temperature may increase. So what will happen if fluid temperature will increase? It will convert into the vapor. And what will happen if vapors will come? Cavitation will occur. Okay, so that is the point we are going to see it in detail in tomorrow. Okay, so in your home you have seen. Okay, in your home you have seen basically. Okay, in your home you have seen that sometimes your pump is not working. So basically at that time what we do, we just open the one nut from your centrifugal pump and you put some amount of water there. Okay, and then again start it. Okay. Yeah, okay, so basically what is happening there, their vapors are forming. Okay, we have to remove that vapors. Okay, we have to remove that vapor. So that is formation of cavitation. Okay, so that is why in first position there is more chances of cavitation because fluid has to travel a certain amount of distance, and in that due to friction the cavitation might occur. But in the third position, if you see in the third position, the fluid doesn't have to travel any distance. Okay, so there will be very less chances of the formation of cavitation. Okay, so that is also known as priming. Okay, and positive displacement pumps. Okay, positive displacement pumps are self priming. This you can remember. Okay, in that there is no problem of priming. Okay, in positive displacement pump this is self priming. Okay, but in centrifugal pump we have to do priming. Okay, we have to do priming. We have to do priming in centrifugal CP pump. Okay, but PD pump self priming, that is a positive thing for this. and that is a negative thing for centrifugal pump. Okay. So this we are going to see in tomorrow in detail, that why there is more friction here. Okay. And that correct my statement that pull is easy. Okay. So for Almira I am talking. Okay. Actually I want to tell you about pump and I told just reverse of that. Okay, so that's it for today's class. Okay, so we will centrifugal pump, Ranjan. Okay, so tomorrow we will be going to see centrifugal pump in detail. Okay, so 2 hours will be required. So tomorrow we will cover centrifugal pump. Okay.